Since people are still joining, I would suggest that we wait maybe half a minute and we start then. Okay, so hello everyone. Hi again. My name is Milan Dojcinovski, and together with my colleague Jan Forberg, we will give this tutorial, which is the first tutorial in a list of tutorials that we plan to organize in the coming months. And the goal is to introduce to the community the latest advancements around the DBpedia technology stack. The goal is to introduce to you the technology stack, the DBpedia technology stack, including the Databus, which is the latest innovation behind DBpedia, and related technologies such as Databus collections. And also we would like to explain how you can build or create database driven Docker applications. So in general, we want people to learn how to replicate the DBpedia infrastructure, since in the past we very often receive questions on how to replicate some technology that DBpedia is hosting. So as I said, I will moderate this tutorial. We will record the tutorial as well, so we will share later the recording with you. Jan will primarily introduce and explain the technology behind. You're familiar with the program, so we center around the program of the tutorial. So there are three main sessions. The first will introduce the Databus platform, and we'll explain how we can upload data to the Databus. The next session is around the collections, and in particular how you can use collections, Databus collections, and use the collections and create customized Databus collections. So this is a very useful feature, and I'm looking forward to Jan's presentation on this. And finally, the last major presentation session is on creating Dockerized DBpedia applications based on data hosted on the Databus. So Jan will explain how to use collections in Databus-ready Docker applications and how to create Dockerized applications for the DBpedia stack. As for the tutorial and the call itself, so feel free to ask any questions. I will try to monitor any questions you might have. Feel free to raise your hand. There is such an option in the software that we are using, or just paste the question. That might be more appropriate if you paste the question in the DBpedia Slack channel. So if you're not on the Slack channel, I added the link in the chat here, so you can register and join the Slack channel. Please mute yourself. Turn off your video if you to save some bandwidth. And as I said, the tutorial will be recorded and we will share with all of you. So let me give the rights to Jan so that he can continue and explain the DBpedia technology stack. Okay. Jan, I guess that's you, right? I'm trying to give you.
That should be my mouse. Yeah.
Yeah.
Hi everyone. Thank you, Milan.
Can you share your screen or?
Oh, it's not sharing the screen?
No.
I don't think I have the presenter role right now. I can't share the screen.
Okay, Julia, are you on the call?
Julia can assign the role.
Yeah, can you?
Yeah, which role Jan is? So Jan, you are just Jan. So now you are the presenter. Can you please try again?
Yes, thank you. All right. So now you should be able to see my screen. Is that working?
Yeah, perfect.
Yes.
Okay.
Yes.
Great. Yeah, so my name is Jan Vorberg, and welcome. And I will jump right into the Databus platform session. And first say a few words to the DBpedia technology stack. So basically, we have the DBpedia Databus, which is a huge data catalog, and that allows you to upload and make your data visible. And then there's, on top of that, the Databus collections that Milan already mentioned briefly, which is a way to organize your data and group it with other data on the Databus. And then on top of that, we have several DBpedia applications and services that work well together with these Databus collections, are really easy to set up using Docker, and makes it fairly easy to set up your own DBpedia chapter, for example, if you want to replicate some DBpedia infrastructure, or you just want to build your own applications on top of the stack, then it's also really easy to set up a local DBpedia, for example, or set up a local Spotlight and so on. To follow this tutorial, there's a few preliminaries. First of all, there's a manual under this link in the slides where the whole Databus upload process is described in detail. There's a couple of resources that I will use in this tutorial. So there's this Stack Tutorial Resources Git repository that you can clone in order to follow along more easily. There's everything already set up for all the three things that I'm going to showcase today. You will need Maven 3.3.9 or higher installed, and you will need a web ID and a Databus account together with a PKCS12 certificate. If you don't have that already, this is not part of the tutorial. There's another tutorial that is going to be linked here in the slides, and I think on the next slide. So if you don't have that already, just follow along in the next step of the session, and just watch for now. And this session is recorded, as we already said, and you can follow along later and do that web ID tutorial first. It is basically a way of authentication for the Databus upload process. Yeah, you need a data project, so you need some data to upload, and that data has to be configured in a certain structure. That structure is already set up in the Stack Tutorial Resources Git repository that is posted above. And yeah, you need a server to host your data. And that's basically it. So let's talk about uploading your data. Again, you need a web ID and the certificate. That is a document you set up on the web that is accessible and contains data about yourself, and is also linked to the certificate. So there's the private key in the certificate, or that is used with a certificate, that the corresponding public key is posted in your web ID and links the two and makes it verifiable that it is you that is uploading. You will need a Databus account. Currently received a lot of messages that there's a problem with that, so we will sort that out after the session. Sorry for the inconvenience. There seems to be a problem with registering a Databus account right now. If you already have an account, you can, let me show that real quick. You can log in to your account on the website, and you can click here on your name to go to your accounts page. And here is a web ID URI field below your other information that you can change. And this here, I have it already open here, is my web ID document. Right, so this is what you will get when you complete the web ID tutorial, and this URI here has to be posted in the web ID URI field to link the two accounts. Okay. So let's talk about the structure of the Databus. The Databus is inspired by the Maven Central and the way that it's a huge catalog for different software pieces. And so this is basically the same thing for data. And usually when you have a data set, you have not only one file, and that's your data set. You have multiple files with maybe over time you change them and you have multiple versions. You have different languages, different formats, compression types, and maybe some other variants. But this whole logical data set and this whole data package is what we call an artifact that describes one topic, and where the everything is just versions and of that data set. So this is what we call an artifact, and your artifacts can be so here your artifacts can be all set then to be part of a group. So you can structure all the artifacts you have more easily. So for example, if you look at the URI below, you have the publisher DBpedia, the group mappings, and then the artifact mapping-based objects. And in that mappings group, there's more artifacts like mapping-based literals and so on, that all kind of belong to this whole topic of mappings or mapping-based extracted data.
Sorry for interrupting. Do you mind showing a complete example of this? Yeah.
Exactly. Yeah. So on the Databus that looks like this, the Databus so for example, these are artifacts uploaded to the Databus, and so this is what an artifact looks like on the Databus. There's some description to it, and most importantly, a file browser where you can filter your the data that has been uploaded. And if there's time later, I will show a more raw view of the Databus to make it maybe even more understandable. It's basically just a huge structure of or hierarchy of publishers. Then all these publishers have groups, all these groups have artifacts, all the artifacts have versions, and then there's actual data sets associated with the versions of artifacts. This is here in this repository. It's basically a more broken down view of the Databus website, and makes it maybe a bit more understandable. So for now, you have to know that this is the way your data is registered in the data catalog, And this is also, note that this is why you have to link your Databus account with your web ID, since this bit here, the publisher, is your Databus name, and the web ID will be the authentication when you upload the data. And this link between the two accounts makes sure that only you, the uploader, are able to use this publisher tag in your catalog URIs. All right. All right. So if you clone the repository of the Databus upload, the Stack tutorial resources, there's a folder Databus upload, and in that folder you can see this. This is the typical data project that is used to upload data to the Databus. And we'll go through all these files and I'll explain what they do. So let's start with a POM XML at the root. This is the. Is that big enough, the text, or should I increase the size?
Oh, it's fine, I think.
It's fine. Okay, cool. So first, let's start with this here. The Databus upload uses Maven, and therefore we have POM XML to configure the upload. And this group POM, so this is POM describes the upload at the group level, defines a few things that you have to configure. First of all, it loads a super POM, so the super Databus POM, and it tells Maven that we don't really actually want to compile any software, that we just want to do the Databus upload, and it deactivates all this stuff we don't need. Second is the group ID. So jump back to the slides here. So this one here is defined by this tag. You have an artifact ID that you can set. This is only a fallback. As you can see here in the hierarchy, we have in the child folder, we have another POM, and this is the artifact POM that describes the upload at the artifact level. So this will override a lot of information that we give here, and some information that we give here will then be overridden by all the artifact POMs. So in this case, we set a fallback artifact ID here, and also a version. Also, this version can be overridden at the artifact level. Modules. Here you have to list all the folders that are in that you want to use as artifacts. So that basically tells Maven that there's more information in any of the child folders. Note that this is cities here, and I put large cities here. And in all the whole tutorial, I exchanged cities for large cities because I already uploaded cities for testing purposes to see if everything works correctly. And yeah, in order to upload something fresh, I changed the name. Now there's a range of properties. The first two are really important. First is package directory. This is the path where your data will be copied to in the uploading process. And it will use the defined group ID and defined artifact ID in the folder structure. I've chosen data for as my directory, and you also have to make sure that when you define this directory, that when the data is copied there, that it's accessible over the internet, and that others can access the data there. And that, so that is tightly connected to the download URL path. This is the actual web address where the data that is copied during the upload process is where the data is then accessible. Also, you can use the tags from this POM in the path. If the data is not accessible and you just copy the data somewhere on your computer locally and it's not accessible, then the upload will fail. The uploading process will verify if your data is actually accessible for others. Next is my web ID URI. This is the authentication mechanism, and this is also together with the PKCS12 file with my certificate file that is also here on my server, and that is linked to my web ID. And so I have my web ID URI posted in my Databus account. I have my certificate linked to my web ID and have both of them referenced here in the POM. Then there are some properties I can set for the data sets as well, such as the license under which the data will be posted, and also some documentation on the group level. So this bit of information will be attached to the HTML view on the Databus website, and you can add some descriptions. It has to use that CData tag, and it supports Markdown, so I can put any Markdown here, and it will also render on the website. And this is something you don't have to change. That's also just for fetching the super POM. So that's basically all there is on the group level. Let's have a look at, okay, there's a screenshot here. Let's look at the POM at the artifact level. And this is this POM, and it's much smaller and basically overrides a few settings on the artifact level, and that's all there is to it. We reference the parent POM here. So this has to match the information from the parent POM. And the interesting tags here are artifact ID. So I set the artifact ID from common metadata, override that setting to large cities. And the version stays the same, but I'm just explicitly stated here again. I don't have to do that, but just to show that I would be able to override it. Same as for the license. This is something I could just omit, or if I desire to override that setting on the artifact level, I can do so. This also works for the other properties. So there's a Markdown file here as well in the folder right next to the artifact POM. This has to be named exactly like the folder. Yeah, so these the folder cities and the Markdown name has to match. In my case, it's large cities, and this is an opportunity to provide additional information to your data set on the artifact level. The first one will be a label. The first line will be interpreted as a label. The second line will be seen as the abstract, and the rest of the document from the third line onwards, you can use Markdown as well, and this will be the long description of your data set. I will show that on the Databus with an example. Do I have a Databus somewhere? Yeah. So let's go here. Right, so this would then be the name. So this is taken from the first line of that Markdown file in the project setup that was used for this artifact. Here you have the second line of that Markdown file as the comment or the abstract. Then you have the long description. So this is the rest of the Markdown file. And down here under group documentation, this is the bit of documentation that was provided in the group POM. Okay, and then last but not least, we have our actual data. So this is a data set I built with a construct query from the DBpedia SPARQL endpoint by just selecting a whole bunch of big cities. And yeah, now after all the setup and configuration, that's how you upload data to the Databus. You hit Maven deploy, and that's basically it. If everything is configured correctly, the data will be uploaded to the Databus and will be then accessible on the Databus website. The Databus will generate a whole bunch of metadata for the data you upload. The data is hosted by yourself on your server, and it will have an entry on the DBpedia Databus and will be referenced there. So let's go ahead and do just that. I have my Stack tutorial resources checked out here, and I will go to Databus upload. And here we can see the project structure again. I have that large cities folder as the artifact that I want to upload, and I have my Groupon. Also note that this is doesn't only have to be one artifact folder, right? So with one upload, you can upload multiple artifacts, and each should have then its own folder, its own artifact POM. Just for simplicity, I just included one single artifact here in the example project. All right, let's go ahead and hit Maven deploy. Fingers crossed. Yep. Right, I'm in the wrong wrong window. So this is my local machine. This is supposed to not work. This is on the server where I actually wanted to do the deploy. So let's do that again. Sorry for that. And let's hit Maven deploy. Right, so this is the same thing again, but this time on the server where I actually want to deploy my files. And there it is actually able to see my certificate and asks me for the password. And there we go. Build success. The data should be uploaded to the databus. The whole process of setting up your data project may take some time. And usually the first time you upload data to the databus, it's quite difficult. But after you have set up your project structure, it's really easy to make re-releases of your software by just hitting Maven deploy, changing a few parameters like versions in your project setup. There's even helper scripts that let you update your version more easily in the project structure. That is also documented on the databus upload documentation that is posted in the slides. So the whole purpose of this is to make uploading data continually much more easy. Right, so let's have a look at the databus. And there it is, my recent upload. And it seems there has been an error somehow and my data has not been uploaded. Okay, that's bad. So let's go with the stuff that I just uploaded last Friday. And we will have a look at that, how that managed to go through and not upload any data. I basically ran the same thing with cities, so there might be some minor configuration error that the databus upload didn't catch. Sorry for that. This is a data set that is already being uploaded using the exact same process. And this is what you actually should see when you access your data set, which is this here. So I have my label, first line from the markdown, the comment from the markdown, and here's the data that was put into the folder. Okay, yeah, I will have a look after the session. I don't think I have time to debug the project right now. Okay, that basically concludes the databus upload. It might be that some of my files were named incorrectly when I switched the names for large cities and made a minor mistake there. But in general, the process should work and go through just like that. Right, let's go to the Databus collection sessions.
Yeah, there is one question in the Slack channel. Rishi is asking, will the packaging jar tag be ignored since the parent project is SuperPOM?
I'm at this point, I don't know what the packaging the packaging tag was there in the example project, and I left it at that and haven't tested it without it. You could try to omit it and see if that works. Maybe it's some Maven specific thing that needs to be there and fails if it's not there. I'm not sure about that, if it's something saying something specific. Yeah.
Yeah, we'll check on this and we'll.
I know that this whole DBpedia Stack thing and Databus and all that, it's just still in the beta phase, and so there's still a lot of some things are not working as they're supposed to. If you encounter an issue, there's also this big report issue button here that will take you to the Git repository, and any issue that comes up there and is posted there that we can then iron out is highly appreciated. Right, let's continue with the Databus collection session. First of all, let's not dive into the collections yet. I will also already just tell you how to access the data on the Databus. The first thing I've already shown you, like the access on the website, but there's another way to access your data, which is over the Databus endpoint. And the Databus itself already also has a SPARQL endpoint where you can query not the DBpedia data, but the Databus metadata. And so the same query here is prepared in the Databus YAS GUI. And when I run this query, I mean, it's already there. It has already been run. This gives me the download link of the file that I've uploaded. Yeah, since the demo effect was kind enough to block the live deployment, this is the Databus deployment from last week. So I have my artifact URI here. In the query, I want all the data sets associated with artifact over artifact property to this artifact URI, and yeah, that's just a simple query that then selects the files from the metadata. If you want to see what's in the metadata, you can also go to the version page and then have a look at the data ID. That's all the metadata that has been generated for my cities artifact, and there you can see the RDF of the data ID and see what information is actually in there. If you wanna know what you can query on the Databus. All this RDF data is contained in the for all of the artifacts on the Databus are in that SPARQL endpoint on the Databus. Okay. I think I don't have to jump into the slides because the next thing will be the Databus collections. So up here, when you're logged in, you're able to navigate to the collections editor on the Databus website. And I already created a few collections here, but I will create a new one now. And a collection is essentially the same thing as this, right? So this is just a query that I send to the Databus SPARQL endpoint to select a couple of download URIs or file links here. And a Databus collection is basically this query and then some metadata like a label, some descriptions, and so on. And also the Databus collection editor allows you to auto-generate these queries. So you don't have to write them yourselves. You can write them yourselves. We also provided that option that you can invite your collection and provide the whole SPARQL query yourself. But you can also go around the Databus website and use your Databus collections like a shopping cart and look at specific artifacts and then put them into a collection. Once you uploaded your data to the Databus, your data set is basically the same, like such a shopping item or shoppable item as much as a DBpedia release. And that makes enables you to easily group your data with other data. For example, take your data set and then take the DBpedia ontology and put that all into one data selection. And these collections and these data packages then are then interoperable with the applications we provide that I will talk about later, and that will plug that data right into the applications. Also makes it easy to share your data with others. So if you want to run some algorithms on some really specific testing data, you can select a certain range of files and share them with colleagues and say to really post them in a publication to specify the data that you selected. Right, so the data when collection has to be published somewhere, and it will be published under my username /collections/something, and that something is the thing that I have to type in here. So let's, do I have large cities already? Yeah, I already have my cities, so I will call this one more cities. Type in a label, type in some description. Let's not do anything super fancy here. I'll just copy that stuff from my other collection and publish my collection. I can always set my collection to hidden, so others are not able to see that on that collection on the databus. It will still work and return the, will enable me to retrieve the query. And if someone already knows the URI, he's already also able to use it, but it will not be shown on your profile. Usually when you go to your databus profile page, it will display all your visible collections that you published. So this is an option to hide your collection or bring it back up. The collection will give me a collection editor view. Will give me 2 tabs here to preview views that are then that are visible on the public view of my collection. So this is the public view of my collection when I actually type in the collection URI, and it shows that, well, there's no data in my collection, and my data table is also empty. So now I can navigate to my cities data set. I think I have that linked in the slides here. Let's go for a new tab here. And since I'm logged in still, I have this drop-down where I can select my collections, and I select the collections we just created and hit add to collection. Now going back to the collections editor, I'll see that I have uncommitted changes in my collection and that I now added in the collection hierarchy my cities dataset. I can see the same file view here. I can even filter my files, so say that I only want turtle files. Doesn't have much effect since I only have one turtle file, but still. And yeah, that's all there is to it. If you want to add more artifacts or even entire groups from your collection editor view, you can hit the plus here and use the database search. So for example, I want the DBpedia ontology in here. Search is still a bit slow. We're also working on that. Maybe some loading widget would make sense here. Yeah. Anyway. Okay, so there also seems to be a problem with search currently, so I will just skip that. There's an option to add custom queries, as I said before, so I could omit this here and just add a custom query where I can really enter the SPARQL myself. Also write a description. Sometimes it's a bit hard to read the SPARQL that someone else wrote. And to make that easier, you can also attach a label and a description to the query to specify what it actually selected. I'll remove that here and commit my collection. And now you can access my collection over this link here. I'll post it in the chat. And that way you can access my collection that I created and see that there's one data set in my collection. And now you can are able to download this data and use it in applications. I'll show you how to do that in the next session now. So that's how you create Databus collections, fetch data, and group it, organize it, and publish it in packages. Oh, sorry, I forgot something. There's two more tabs here in the collections view, which is query and download URLs. This gives you instructions to actually download the data. Right, so here's an auto-generated bash script that if you just copy paste that to your console, will pull the data from the databus using that bash script. Here's the entire query of the entire collection. And here you also have a list of plain text download URIs. This collection feature is also how we are going to publish DBpedia datasets in the future. So if I go for the DBpedia publisher collections and latest core, this is the latest DBpedia release. And this collection is set up in a way, the query is set up in a way that always selects the data sets with the latest versions. So when there's a new DBpedia release, this collection will always point to the latest stuff. Here, the data table is much bigger than in my other collection, with all the data associated with a DBpedia release. Also, the hierarchy looks a bit more extensive, and yeah, the query is also quite huge. But basically, it does the same thing. Gives you a huge list of files and a way to query the data from your applications. So this is also how you would potentially load the data in one of your own applications. Each language support has some HTTP client, and that way you can just query the collection URI with the exact header text SPARQL. This will return the SPARQL query, and then you can send that SPARQL query to the Databus endpoint and get a list of files. All right. So let's have a look at the Dockerized Databus applications. So we already set up a few applications that work well with the Databus and the collections feature. And this is usually the the rough architecture. It's a really loose coupling between the applications and the databus, but it worked quite well so far. What we have is that we use Docker Compose to start up multiple containers at the same time. Through the Docker Compose YAML file, all the containers can be configured, and the containers then communicate over shared volumes. So they have all basically access to the same folder. And an important part of that architecture is the download container. So it's one of the containers specified in the Docker Compose setup. This download container receives a collection URI. So in that Docker Compose file, you write you set your collection URI as an environment variable, and then the download container downloads that data from the databus into the into a specified folder that is also accessible to the application container. When it starts downloading, it will create a download LCK file that any other container can then pull for. And once that download log file disappears, the other containers will know that the download container has finished its job and is done with the downloading. Then the application container may, of course, use any other container as helper containers, for example, a database or whatnot. And once the download is complete from the download container, the application will then start to run in its own container. So as an example, we have the Dockerized DBpedia, which is a composite in the Docker Compose of the download container, so that its job is only to pull data from the databus. We have a Virtuoso container that is the database where the DBpedia is installed and loaded to. And we have the application container, so to say, is the Virtuoso loader container. Its job is to wait for the database to start, wait for the download to finish, and once it's finished, load the data to the database and then install the DBpedia plugin on top of it. This is also part of the tutorial resources. That's the Dockerized DBpedia folder here. And, oh, all right. So I will remove these folders real quick. So that's from the last test run. And all there is in there should be that Docker Compose YAML file. Let's have a look. Here you can see the 3 containers specified in the Docker Compose. First one being the download container. The download container basically just runs the bash script that is available on the collections view, right? This one here. It's all there is to it. It just pulls files from the databus. There's other download clients available for the databus. For example, the databus, the official databus client, and that client is already also supports file conversions. So you can convert stuff that is only available as n-triples on the databus as turtle or any other RDF format. And there's also plans to provide mappings to that download container, so it actually can convert, for example, CSV into RDF. Right, so this minimal download client is basically just downloading files from the databus by fetching the query over the collection URI and then firing the query to the databus SPARQL endpoint. And I specify the download directory, so this is where I want the data to go. And this is my collection URI. I can change that to what did I pick as a name? More cities, right? Right, there's a DBpedia, there's a Virtuoso database, and there's the loader script. They share that downloads folder, and the loader looks for, checks for the finished download, checks for the store to come up, and then installs everything. So in order to run one of these DBpedia's Databus ready applications, all you have to do is run docker compose up. And all three containers are doing their thing, waiting for each other. And that's it. The loader script, the loader container finished, and the store keeps running. And now I can access, I think it was 88, 90. So this is now running DBpedia on my local host, only running on really minimal data. So if you want to deploy the whole DBpedia on your own server, you would have to use in the Docker Compose would be the latest core collection. Right? It takes the latest core collection URI, post it into the Docker Compose, and hit Docker Compose up, and you will get, well, it will take a lot more time, but when it's running, it will contain all the data. So this is starting quite quickly now because, yeah, it's only like 1.2 megabytes of data containing large cities. All right, let's have a look at the next Dockerized application that is available currently, which is the DBpedia lookup. I can have a look at this Git repository. There's an extensive documentation because this time it's not so easy configurable. There's this Docker Compose YAML file, but since there are so many things to configure now, it also uses an additional app configuration file that is also in the same syntax in YAML and lets you specify a lot of things. Still, this thing is also a composite of the same download container and the lookup container. So this time only two different containers. And this is also part of the Stack tutorial resources. Name DBpedia lookup. Okay. So in here, I also forgot to remove the folders. So I'm going to do that now. Sorry for that. Index and also the TDB. Right. What did I? Oh, crap. All right. So everything that is in here should be these files. The Docker Compose, which is the most important thing, then an additional application configuration and some template that is used for displaying my search results from the DBpedia lookup. Let's have a look at the Docker Compose. Yeah, as described in the slides, only two components. The download component doing the exact same thing, still referencing my large cities collection, but I think I already showed that it's actually working with any collection. So I will just leave it like it is. And my DBpedia lookup container, yeah, if you're interested in any of the specific configurations, check out the Git repository. This one here is configured to, I think, only fetch labels and comments and index them on all the resources it finds. And again, really simple setup or startup. Docker compose up, that's all I have to run. Data. Now my lookup application is waiting a bit for the download to finish. And now that it's done, Yeah, the lookup is running on my local host. And there's already a query here prepared. So this is searching for Berlin, but I could maybe also go for Los Angeles and get the DBpedia lookup search results. Note that this container is now highly configurable. So for example, the search on the Databus website is using that same Docker container as the DBpedia lookup. So it also is used to index and make the Databus data searchable, which currently has a problem, but that's basically how the problem with the refreshing process, and not a problem with the lookup itself. So this container should work correctly. Next in the stack is the DBpedia Spotlight. DBpedia Spotlight is not working with a download container, so it's basically just querying static data from the databus. It's working with a databus, this time not with a download container. This makes sense because it really needs a specific set of or piece of data to work with. But yeah, it's also easy to deploy this Spotlight. If you're interested in how to deploy it, it's not part of the session here. Visit the provided links, and it should be fairly easy to also set this up and get this running with Docker. Yeah, here's also some instructions in the slide that sums up the most important parts. And in the end, you should have that Spotlight running on your local host as well, or you can deploy it on your server. All right. A few words to building your own applications for the DBpedia Databus. I mean, I've said this before, but to sum it up, basically, you will need this sort of setup. You can use one of the download containers available on Docker Hub under the DBpedia account. Use them in your Docker Compose, and then build your own application by checking the a shared volume for a download log, or you even listen for the download container to shut back down, and that will enable you to see that the download process has finished, and then use the download data locally in your applications. All right, that basically concludes my tutorial. Thanks for your attention, and I'll give it back to Milan.
Yeah, thanks, Jan. So we have a few minutes left, but there are some questions in the chat. There is one question on the lookup. Can I use the lookup container to index and search inside my own dataset?
Yes, you can do that. Let's go to the lookup application Git repository, and there is this huge README that explains a lot of the things that are now possible with the lookup. Here is the application configuration that I was talking about. Yeah, it's not in the Docker Compose, but it's an additional configuration file. And here you can, so usually when you set up a search index, you need documents, right? Resources, and that you attach fields to it, indexable fields. So the search works on these search fields, and so all you need to extract from your data to enable search on your own data set is to select key value pairs or resource field pairs. And you can do that in the application configuration by specifying small SPARQL queries. You put the data, you load the data into the lookup application. Loads the data into a Jenna TDB2 database, and then runs these small SPARQL queries to select key value pairs, and then puts these key value pairs into the Lucene index. So there's really only few limits on what you can actually index. So as an example, for the Databus, we even you can use one of the Jenner properties to split your URI into these small URI parts, and we all and return them as bindings. So we also indexed all the parts of your artifact URI as fields in the Lucene index. So that's how you can do that on your own data. And there's more stuff, like you can specify the scoring function based on numeric fields that you return. For example, we use the ref count is now a configurable part of the scoring, and there's a lot of stuff. It's all described really extensively here. So yeah.
Good. Thanks. Yeah. Okay, and there is also one more question. It would be very nice to concretely explain what is the path of Wikipedia data in the infrastructure. So I believe the question is related to whether the Wikipedia data is published on the databus. So for the moment, this is not the case. However, the releases that are done, they are correlated with the actual version. So for example, the latest version, DBpedia release version is 2020 June, 1st of June. So basically this release is for the XML dump, Wikipedia dump of the same date. So it's 2020 June 1st. So this is basically what the relation between a particular DBpedia release and particular Wikipedia data dump. Yeah, I don't see any other questions. So maybe I think we need to close the session very soon. So if I can get the presentation back. Julia, can you give me the moderation rights?
Yeah, I gave you the presentation rights. You can share your screen.
Yeah, okay, perfect. Okay, so let me just say a few words at the end. So in summary, what we covered in this tutorial was the Databus platform, the DBpedia Databus platform. Jan explained how you can upload data on the database using the Maven plugin, and how you can configure your own collections and work with this collection. That was in the first part. In the second part, Jan explained how you can consume and use DBpedia data from the database and create a Dockerized DBpedia instance. So basically, this is how you can replicate the DBpedia infrastructure using the database, and also Jan explained how you can create Dockerized applications based on the data hosted on the database. And he explained here 3 Dockerized applications: the Dockerized DBpedia application, the lookup, and the spotlight. I would like to also mention that everyone can become a member of the DBpedia Association. So there is a formal entity at the INFI Institute at the University of Leipzig. There are 30 plus members. So if you want to support DBpedia and become a member, feel free to join. There is a link in the slides where you can find more information on this. So there are many research institutes as well as enterprises and companies that are part of this of the association. As for the events for 2020, there was one event about 2 weeks back, which was collocated with the LDAC 2020 workshop series. We organized a DBpedia workshop. Today is the first DBpedia Stack tutorial that we plan to improve and organize again in August, late August or early September. We plan to organize organizational chapter setup meeting, which will happen at the end of July or early in August. So if you would like to set up your own DBpedia chapter for a particular domain, for a particular language, or based on a location, feel free to join this meeting. We will publish the date very soon on the DBpedia website. There will be also a 2 weeks hackathon, datathon, which will start on September 21st. More information we will publish on the website soon. And also we plan to organize a conference which will happen on October 6th. The focus on the conference is our knowledge graphs in action, DBpedia link geodata and geoinformation integration. So feel free to join. There is a registration link in the slides where you can join. So finally, I would like to thank everyone for joining this tutorial. It was very nice to have you all here. We received over 150, or more precisely 158 registrations, which is very nice number. If you want to follow the DBpedia community, feel free to join the forum, join us on Slack, help improve the mappings on the mappings.dbpedia.org. If you want to check out any code behind the DBpedia technology stack, there is everything on GitHub. There is a link on the Databus platform. Follow us on Twitter, and for every events we publish a post on the wiki.dbpedia.org/events website. So thanks again for joining this tutorial. If you have any question, feel free to paste on the Slack channel or write us at dbpedia@infi.org, or paste the question on the forum. So that would be all from our side. Thank you again for joining, and talk to you in another occasion.
Yeah, thanks.